This video is brought to you by Factory Direct Trains. Visit factorydirecttrains.com and check out their wide selection of model railroading products and supplies. Hey everybody, it's Jimmy from the DIY and Digital, and today we're controlling a snap switch with an Arduino. Welcome back everybody. First of all, if you haven't already, go ahead and hit that subscribe button so that you are eligible for the DIY and Digital 5,000 subscriber giveaway sponsored by FactoryDirectTrains.com. I'm giving away a Broadway Limited N-scale locomotive and an Athearn HO scale locomotive. Now, let's get down to business. Here are the parts we're going to need to set this up. An Arduino UNO, an Arduino 4-channel relay shield, a remote snap switch, a button, a 1K resistor, and a 12-volt power supply with an adapter. You'll also need some Dupont connector wires. So let's go ahead and set this up. Now you'll notice that I've put a strip of yellow electrical tape right here on the USB connection of the Arduino. That's because the contact points on the relay shield are a little long, and I wanted to make sure that there was no short circuiting with the metal covering. So just like any other shield, we're going to go ahead and slide this on top of the Arduino UNO. Now we're going to set up our snap switch. Now the way that a snap switch works is that the center connection is going to be your ground, and your left and right connections are going to be the power connections that are going to make the motor snap back and forth for the switching action. I'm going to take some Dupont connector wires that I have bent in order to fit this properly and connect them right here. You can make your connections a variety of different ways. Just remember that the center is the ground connection. I'm then going to take a green wire for one of the power connections and a blue wire for the other power connection. For prototyping purposes, I'm just going to tape these in place. You may have screws that you want to screw in more permanently. The first connection we need to make is the ground connection on the 12-volt power supply adapter. Remember to connect the ground to the negative side of the adapter. Next, we're going to take the positive side of the adapter, which we've already put a small connector wire on, and we're going to attach it to the center terminal port of the number 2 relay on the side of the relay shield. This is what's going to be providing the power to throw the turnout. Next, we need to jump the positive from the number 2 relay to the number 1 relay. So we're going to take this and connect this jumper wire from the center of the number 2 relay to the center of the number 1 relay. The next thing we need to do is take the power leads from the switch motor and connect them to the relay shield. One needs to go in the left port of the number 2 relay, and one needs to go in the left port of the number 1 relay. We then need to set up our triggering mechanism, which is going to be the exact same as the Kato Unitrack triggering mechanism, a momentary push button. We simply hook up our power connections, we then put the 1K resistor on one side of the momentary push button, and connect our positive power to the other side. We then connect our ground connection through the other side of that resistor. On the other side of the button, we're going to go ahead and connect that to pin A0. That's going to be our sensor input. Alright, let's head to the computer for a little bit of coding. Okay everyone, we are in our Arduino IDE, and we are going to go ahead and do a little bit of programming. So the first thing we need to do is we need to establish a few integers. So what we're going to do is I'm going to go ahead and set this up so that if you want to hook up a red and green signal light to it, you can, and just have it all pre-programmed for that. I'm not going to hook that up with this particular setup. I did do that with the Kato Unitrack switch setup, and you can check out that tutorial right here. But let's go ahead and do these integers. So we're going to do int red equals 12, int green equals 13, and then we're going to do int button equals A0. Alright, so now we can go ahead and go into our setup, and this program is going to be very similar to the Kato Unitrack turnout program. It's actually a little bit simpler than it as well. So we're going to do void setup, and then we're going to do pin mode 6 output, and what that's going to do is that is establishing pin 6 as output, and that controls a relay. We'll be using 2 relays to throw the turnout. Make sure I have all my formatting correct. Then we're going to do pin mode 7 output, and then we're going to do, I gotta be able to type, guys, it's bad, pin 7 as output controls a relay. Then we're going to do pin mode button is an input, and that establishes the button as the input. And then we're going to do pin mode green output. And I'm just going to type all this out for you guys. It's pretty much identical from this point to the Kato Unitrack switch. I've just done some different modifications to the loops. So let's see here, pin 13 as output, and then last but not least we're going to do pin mode red output, and establishes pin 12 as output. Okay, so that's everything we need to do right there, so we can go ahead and establish. We're going to enumerate some different states just like we did last time. They're pretty much identical to the Kato Unitrack switch states. So we're going to just go ahead and knock those out right here. Off 1, comma, not a semicolon. And I'll tell you what, guys. There we go. Had to get my typing right there. Off 1, comma. Off 2, comma. Straight, comma. Turn, comma. And those are going to be our 4 states, just like last time. And then we're going to do switch states, switch state, equals st underscore off 1. So that's just establishing our default state as off 1. Alright, so now we can go ahead and go into our loop. And right off the bat, we're going to do int button read equals analog read button. So that's just saying that button read, it just tells it to read whatever that button pin is sending. And then we're just going to do a delay of 200 and switch state. So now we need to make a bunch of different cases. We're going to start a new bracket here. We're going to do case state off 1. Then we're going to do switch off 1. And we're going to say that button read is the variable. It's going to be like and we're going to say break. Then next we need to do case st underscore off 2 switch off 2 button read, and then we're going to say that sets up changes to st off 2 break. We're going to do this for the straight and the turn as well. Switch straight. And I'll set that up, do the break. We'll do case turn switch turn button read, and we'll say that sets up changes to st underscore turn. Okay, so those are all our cases right there, and then we'll put the last break in there, and that's it for the loop. So now we can start going into the individual states. We're going to go ahead and go to a new line, and we're going to start off with void switch off 1 and do int button read we're going to start off with digital write 6 low, and what that does is that keeps relay 1 in the off position. Then we're going to do 7 low. And that keeps relay 2 in the off position. So that's it for that. Basically what it is the relay shield has pins 4, 5, 6, and 7 as the control pins for the relay to say that they're on or off. So what we're doing is we're going to be using relays 1 and 2, which are pins 6 and 7. And so we want them to be off the way that we've wired it until we're ready to turn them on. So now we need to establish what's going to change that. And we're going to do if button read is greater than 500. Put our bracket there. Switch state is equal to st underscore turn. Okay, so that is all that we need on switch off 1. So now we're going to go to void switch turn, integer button read, then we're going to do digital write 6 high, and I have a slight formatting error. I completely forgot to put semicolons after these, so there we go. We're going to say that activates relay 1. Then we're going to say digital write 7 low. Keeps relay 2 off. Then we're going to put a delay of 200, which if you remember correctly is 0.2 of a second because it's in milliseconds. And then we're going to do digital write 6 low. That turns off relay 1. Digital write 7 low. That keeps relay 2 off. And then we're going to say switch state equals st underscore off 2. And that changes it to st off 2. Okay, so that's everything we need right there. So once again, just like the Kato turnout program, we can literally just copy off 1, and we can just change to off 2, and then we can set this to straight. So it needs to switch to switches to straight. Then we can copy the turn and do a few modifications to it. We're going to change it to switch straight. We need to reverse and have relay 1 stay off, so we're going to make that low, and we're going to make relay 2 high or 7 high, and then we need to change it to state off 1. And then we'll just change our notes. And that should be everything. So basically what we're doing is we have to turn on one relay or another to activate the little magnet in the motor to go back and forth. So that's basically why we need to straighten the turn. So let's go ahead and check this. And alright, so let's go ahead and verify that this works. Alright, so it works. Let's go ahead and upload to the Arduino and go test it out. Alright, we've loaded our code and let's give this a test run. As you can see, when I push the button, the turnout throws. You can also see the 2 different lights lighting up on the relay shield, indicating which relays I'm throwing. And that's it, guys. I hope you really enjoyed this tutorial, and I hope it helps you out on your layout. I would love to see ways that you guys would implement this on your layout. You can leave that in the comments below. Until next time, I'm Jimmy from the DIY and Digital. Happy railroading!